Good morning, good afternoon, and good evening, ladies and gentlemen, and welcome to our free webinar, How Silicon Additives Combine Performance and Durability in Architectural Coatings. And this webinar today is sponsored and will be presented by the DOW Chemical Company, further on very short, just DOW. My name is Detlef Sassenberg, European Coating Scientific Consultant, and I will guide you through today's online event. On our webcast today, we will learn how silicon additives positively will affect and improve the performance of architectural coatings. Before we start, just a hint regarding your questions. On your screen, you can find a box for your questions to our speaker. Please type your questions or comments into this box at any time during the presentation. We will collect your questions and they will be transferred to be answered directly by DOW. So there is no discussion after the presentation as usual. As well, the presentation will not be available or published on the usual websites. And now some words about our speaker. So please welcome Dr. Stefan van Oyke. Hello, Stefan. Perfect.
Hello.
Okay, Stefan.
Hello,
So
good afternoon.
Good afternoon. So as far as I know, you are senior TS&D. TS&D stands for Technical Service and Development Scientist at DOW Coatings Materials. And far as I read your CV, you instead of blood, you got silicone in your veins. Is that right?
That is correct. That is correct. I'm coming to DOW from the DOW Corning joint venture initially. So I spent all my career in the silicone environment. That's correct. Yes.
So we can really say that we have a profound expert here today, who will tell us about silicone. And of course, in your CV, we all can see and read that you are also an expert in regulatory compliance expert. This is also
Yes.
an expert you're an expert in that. So is there anything that might be helpful that we will know? Can we hear something about in your speech, or is it just about the products?
No, this is just going to be about the product. There's no input on regulations or product stewardship at this time.
So you spend a lot of time in the UK. That was research laboratories Barry at UK at DOW. So now you are back home, as far as I understand. So back home in Belgium in Senef.
Correct, indeed. Yes, I started my career in DOW Corning, then in the UK at the time, and I've now been back for it's already 20 years that I've been back.
20 years now.
Yes.
Okay. So
yes.
So it's not about coming back home. You're already there as well. Okay. So if I would be thinking about or hear about your products, about silicone additives, I would like to quote Paracelsus. Paracelsus is an alchemist, physician, and astrologer in the 16th century, and he said, "All things are poison, and nothing is without poison, but the dose makes it clear that a thing is not a poison." So this is what I'm thinking about if I hear about your products. So what we have here today is that we learn how to fight the battle between surface tension and dosage to defend high performance of waterborne architecture coatings. Is that right?
There's a good part of it, yes. Yeah, it's always a balance, especially with silicones. Okay, yes, finding the balance.
So if a good part, there is a much better part. And I think we should now start to listen to the good and to the better part. So the audience is used to fun.
Okay, then I will get started with the presentation then. So again, good afternoon, good morning, good evening to everybody, and welcome to this presentation. As was introduced by Detlef, it will be my pleasure today to present you with technical information concerning the characteristics and performance of some of our key silicone additives for architectural coating application. We'll start first by a short introduction concerning DOW coating materials and the main high-level points concerning the challenges faced by architectural coating. This will be followed by a technical review going into more details on how properties of coatings can be improved by the selected use of silicone additive, and this specifically for 4 endpoints of foam control, hydrophobization, leveling, and matting properties. So, starting with DOW coating material. DOW coating material has achieved a position as one of the world's leading suppliers of binders and additives, and is providing technologies for 4 main segments in architectural coatings. Paint formulators benefit for a comprehensive range of emulsion polymer for interior and exterior use, including wall and trim coatings, primers, stain and masonry coatings. Our industrial coatings offering provides, amongst other, excellent adhesion to a variety of substrates, enhanced resistance and fast drying for road marking paint application, industrial wood coating, liquid applied sound dampening, metal coating, and can coatings. In our paper coating portfolio, we're including technologies for paper and thermal paper coating and paper and board barrier coating. DOW coating materials offer additionally an extensive portfolio of rheology modifier and thickener, dispersant, silicones deformer, slip mar, and wetting agent. DOW coating material is also one of the pioneer and global leader in the category of opaque polymers. Our customer-focused innovation continues to address formulators' critical needs, such as improving sustainability, while still advancing performance, enhancing environmental durability and performance, reducing application, manufacturing, and processing costs. This presentation will focus on how the right silicone additive can contribute to obtain premium dry film properties and enhance the durability of architectural paint formulations. The first part of my presentation will cover the deforming additives. Foam control additives are probably the largest category of silicone additives used in coating application, and they can be used for the control of foaming both in the manufacturing and the use stage of paints and inks. One of the steps in the journey of making environmentally friendly, high-quality paints is the continual development of efficient and compatible foam control agents. These additives can be used to prevent foam formation, generally called deformer, or destroy existing foam, generally then called anti-foams. Just for the sake of clarity, I will probably use this term interchangeably in my presentation. It's kind of a use, so don't pay attention to that. To be efficient, a deforming additive needs to show some incompatibility with the foaming media in which it needs to be efficiently and uniformly dispersed. The mode of action of the deformer is for the dispersed particles to migrate into the surfactant stabilized by a layer of the foam bubble and disrupt the film by adsorption and dewetting. This will result in bursting of the foam bubble. Striking the right balance between deforming efficiency and compatibility in the paint film is key. When the deformer is absent, ineffective, or incompatible, different coating defects can be observed, which compromise the quality of the paint and the substrate protection. For example, pinholes, orange peel, fisheyes. Besides compromising the quality of the coating, undesirable foam limits the formulation option and can have costly and damaging impact on manufacturing capacity. The challenge for the formulator will be to find the right balance between the effectiveness of the deformer and its compatibility in the formulation. Improved deformer compatibility reduces the risk of defects, helps with the incorporation in the formulation, but reduces efficiency. On the contrary, improved efficiency will be linked to higher active hydrophobicity, long-term defoaming, but increased risk of creating a defect. The traditional polydimethyl siloxane or PDMS-based defoamer, as used a lot, for example, in home care applications, although very efficient, are likely to induce a lot of incompatibility and create surface defect, phase separation, and maybe even recoatability issue in paint application. Defoamer for coating applications are based on a different architecture and functionalization. Silicone polyethers is the leading technology for defoamer that presents improved compatibility with a variety of coating formulations. One advantage of this technology is the modular flexibility, which allow tuning the properties by variation in the type and amount of polyether modification on the silicone backbone. These changes give access to defoamer with improved compatibility with organic systems. The coating defoamer range is divided into three main categories, providing a range of effectiveness and compatibility and allowing flexibility based on the formulation needs and the specificity of the application. The first category are the polymeric defoamer, which are basically just hydrophobic polyether modified siloxane polymer. These products offer, thanks to their compatibility and ease of incorporation, the least risk of creating defect in sensitive formulation, but at the cost of a reduced effectiveness. It's always the effectiveness versus compatibility balance. These polymeric defoamer are free from hydrophobic solids and are thus recommended for the most sensitive applications. The second category of products are compounded defoamers. By this word, we mean that they're also based on hydrophobic polyether modified siloxane, but formulated with hydrophobic solids, in this case, hydrophobic silica. The role of the silica is to increase the rate and the effectiveness of disrupting and rupturing the foam bubble, leading in the collapse of the foam. The featured product in this category are offering a range of increasing efficiency to adapt for formulation requirement, going from one of these products to the other. Finally, the third category of product is quite different. Those are the emulsion-based defoamer, in which the silicone component is dispersed in a water phase and is usually a more complex silicone composition, also based on polyethers, but not only. The main advantage of delivering the defoamer actives in an emulsion are ease of use and incorporation into the formulation. This category of defoamer can also offer a faster knockdown of foam when this is an issue, for example, in processing or in application. In the featured range of the product displayed on the screen, we can see again defoamer with various active content and efficiency, giving the formulator multiple options. The table in this slide is an indication because it's indicative, as anti-foam efficiency and compatibility is extremely dependent on the formulation. But as a generality, for standard architectural coating application, the first go-to recommended products are highlighted in this slide as DOW 107F additive or 8590 for compounded defoamer, or DOW 108F for the silicone, the water-based silicone emulsion defoamers. Okay, so again, these are the initial go-to product for an initial investigation. And based on the observed results in the formulation, selection can be adapted to offer either higher or lower efficiency, higher or lower compatibility as needed based on the initial results. Between the compounded defoamer and the emulsion-based one, the choice can be, as stated above, based on the degree of the ease of use required, or the incorporation needed, with the emulsion-based deformer presenting the easiest incorporation and equipment cleaning ability, but the compounded deformer offering a lower sensitivity to shear applied in the formulation process, for example, in the mill base. Just as an visual illustration of the efficiency of some of the featured compounded deformer in this case, the following slides demonstrate the effectiveness of our primary go-to product in comparison with a selection of traditional deformer. In this case, competitor 1 is a silicone deformer with strong efficiency. Competitor 2 is a silicone deformer with good compatibility, while the deformer number 3 is a different technology, is a mineral oil based. Those 4 deformers were compared in an acrylic-based formulation, characterized by a 29% pigment volume concentration and 37% volume solid. And in this case, show the results or the observation of the film based on drawdown on test charts. We can see that the formulation containing our featured product shows both excellent appearance relative to competitor 1, which presents many coating defects. Deformer 2, again, the silicone with good compatibility, shows a good appearance and good gloss level, similar to our featured product, but required 4 times the loading to achieve the same performance level. And finally, for the 4th option with the mineral oil, although the appearance is good, we're observing what is typically observed with mineral oil-based deformer, which is a lowering in the gloss level in the final film. When comparing the same formulations, but this time applied by roller application on a test substrate, we can see clear difference in the deforming performance between the 4 materials. In this case, after drying in controlled conditions, the film were analyzed by automated image analysis, which really identified each and individual bubble formed in the coating due to bubbles trapped in the final film. And these bubbles are indicated by the red circle on the images. As we can see, there are significant differences and variation in the ability of the tested deformer to control the appearance of these defects. We can see that deformer number 2, which, if you go back to the other slide, was showing a good appearance of drawdown, there are multiple, the highest level of bubble formation when the paint is applied using roller. Mineral oil deformer, competitor deformer number 3, does present a lower level of defect formation, similar to the featured material. But as a reminder, this material required 4 times the amount to achieve this performance and resulted in a decreased gloss level in the drawdown film. And just finally, still for the same featured material, in this case, looking at the comparison with the mineral oil-based deformer, we can see the results of the pickup resistance in a slightly different paint. In this case, it's a 46% pigment volume concentration and 36% volume solid, again, based on acrylic binder. We can see a clear difference in the dirt pickup resistance between the 2 samples. And when the actual surface of the dried film is observed by microscopy, you can see on the left of the screen that the surface of the film containing the featured additive is significantly smoother than the one based on mineral oil. probably indicating both the improved performance and compatibility of the material in the formulation. So next category of product that I will talk about are the hydrophobes. Water resistance or hydrophobicity of the final dried paint film is a key property in coating application. Hydrophobic additives, silicone additives, specially designed to provide these properties in exterior or in high humidity interior type application. And silicone-based additives are particularly well suited for this type of application, thanks to combination of their performance attributes. First, high level of hydrophobicity, leading to a increased water contact angle and reduced surface wetting. They can also offer reduction of the capillary water absorption without occlusive properties, thus not impairing the breathability of the coating and the ability of water vapor to permeate across the film and avoid accumulation in the substrate. Silicone additive, if properly formulated, can also react with the surface, binding chemically and resulting in improved durability compared, for example, with organic wax-based hydrophobic agents. And finally, particularly pertinent for exterior application, silicone additives, thanks to the silicone chemistry and silicone properties, are not affected by UV light, hydrolysis, or oxidation, leading to excellent maintenance in time of the performance when exposed to the elements. And we'll see that in the next slide. Three main categories of silicone may be used as hydrophobic agent in isolation or formulated in composition: resins, silanes, and silicone fluids. Silicone resins are characterized by the ability to form a film that will block the pore of the substrate and reduce water absorption. Silanes can react with the substrate and other component of the paint, providing durable hydrophobic character. And silicone fluids will help with water beading and surface spreading. These materials, as I said, can be combined to obtain the desired performance properties. For water-based architectural application, the featured products on these slides are based on combination of these ingredients. The primary lead product for hydrophobic application, the DOW 87 additive, is based on fluid silicone oil. Thanks to this, the presence of this silicone fluid, it increases the water contact angle of the dried film and can provide much needed beading properties. An often requested visual indication of the hydrophobic character of the dried paint surface. Based on resin technology, the second product, DOCIL 902H additive, can be considered both as an additive and as a co-binder. It is generally used at higher loading levels for optimum efficiency in water absorption reduction, reaching 8 to 10% by weight in typical application. In very specific applications such as silica paints, the usage content of this resin-based additive can be increased to represent 40% of the total binder content. Thanks to the resinous component, the additive will provide a reduction of the water penetration level across the coating. If, in addition to the hydrophobic characteristic, visual clues of hydrophobing through beading are required, the material will have to be combined with the first featured product that I just discussed before. Finally, a combination of fluid and silane technologies is used for the third featured hydrophobe. This additive is specifically recommended for the control of snail trail or surfactant leaching in freshly applied exterior architectural paint, as I'll detail in a coming slide. Starting with the first feature product, based on silicone fluid, the effectiveness of this material is illustrated in the top box of this slide, where the addition to a formulation clearly increased the water contact angle from 112 degrees in the control to 120 degrees in the sample, while at the same time significantly lowering the water absorption by a factor of more than 4 times versus control. And in both cases, significantly better when compared with a traditional competitive silicone resin emulsion. Coming back to the exterior durability, the good exterior aging properties of the resin-based additive and of silicone material in general can be seen by the observation of the water contact angle of coating with or without the additive after 1500 hours of UV exposure in a QUV chamber. While both of the formulation started with very comparable contact angle, after 1500 hours of UV aging, we can see that a significant difference can be observed with a reduction of more than 60 degrees of the water contact angle for the formulation free from the silicone additive. Surfactant leaching is also referred to as snail trail, can be a significant issue in specific formulation. This phenomenon refers to the extraction and leaching of water-based soluble material from the coating in the few hours or days, couple of days after application of the paint. And it generally takes place when rain or dew condensation occur within this short period of time and before the paint film has the required time to fully form. It will show up with a very distinctive trace of the exudate, as can be seen, for example, in the particularly severe case in the upper right picture on this slide. Now, despite the name of surfactant leaching, the problem is not limited just to the presence of surfactant in the formulation, but can be made worse by the presence of any type of low molecular weight water-soluble component in all the constituent of the formulated paint. And while the most significant handle to overcome significant leaching issue is in the selection of the binder or the dispersant, the use of a specific additive has also been demonstrated to have potential positive benefit. In particular, reactive silanes such as the one presented before, the DOW 904H additive, can significantly limit or eliminate leaching of water-soluble species in the couple of hours following paint application. The mechanism of action is probably via rapid migration of this additive towards the surface of the coating and reaction with other coating ingredient to help in forming rapidly an hydrophobic surface, limiting the ability of water droplets to extract soluble water species from the film. In the lower left picture, and it's not always easy depending on the screen and the presentation to see difference, but you can see clear difference in the film appearance with and without the use of 2% of this additive in an acrylic-based formulation using the simple water drop test, in which a couple of drops of water are applied on the freshly dried film, left on contact for a while, and then allowed to run out. And you can clearly see traces of these water droplets in the control formulation, but not in the formulation containing the snail trail reduction additive. Now, for the third category of products in the review are the silicone additive designed to improve leveling benefit. The additives of this category are acting at the level of the surface of the coating, and by this action may present multiple end benefit beyond leveling, but we'll focus purely on the leveling benefit for this presentation. Leveling and slip are related. They're two properties that are ultimately linked to surface phenomenon. Leveling is an important property that will determine the quality of the final film. Leveling is also required to obtain a smooth film surface and a more pleasing aesthetic. It can be defined as the degree to which an applied coating flows at the surface of the substrate to create a uniform defect-free film. Poor leveling is attributed to differences in surface tension across different coating components and the substrate. The usage of the silicone leveling additive based on surface active polyether siloxane again helps to create a more uniform surface tension across the coating, preventing gradients leading to the appearance of Marangoni flow, and which result in the reduction or elimination of defects such as cratering and orange peel. Slip is also related to the migration of siloxane to the surface of the coating, but in this case, reducing the overall surface tension and providing surface modification by formation of a thin lubricating layer on the surface of the film, providing protection against marring and modification of the tactile properties, thanks to the lubricating properties of this layer. To illustrate leveling benefit, in this case, we'll focus on one featured product, DOW 402LS additive. As an example of improvement in leveling performance, we can see here on the left side of the screen that the incorporation of this additive in, again, an acrylic-based formulation of 31% pigment volume concentration and 37% volume solid improve the hiding performance improve the hiding performance. On the left slide, you can see this is applied by roller. Sorry. On the left side, we can see again the examination of the surface of the coating by microscopy, showing a clear difference in the smoothness of the surface with the formulation using the featured additive. Now, in this set of pictures, we can see the effect of adding the feature additive in function of the application method, again in an acrylic-based formulation. The first column on the left corresponds to drawdown on Leneta chart using a leveling bar, and a clear difference can be observed between the control sample and the sample with the additive, resulting in a significant difference in the visual rating for the sample containing the additive. The middle column shows leveling difference between brushed samples in this case, again with better leveling observed for the sample incorporating the additive when compared to the control. And in the last column on the right, we can see the improvement in contrast ratio for roller applied paint on a contrast chart with the improvement in significant improvement in the value of the contrast ratio, which translate to better applied hiding. And again, I mean, this is just for an illustration, but examination of the topography of the surface of these various samples, in this case by optical profilometry, shows much improved smoothness of the formulation containing the featured material. In this case, the difference of color on the slides indicate the peaks and troughs of the surface of the dried paint film. And I will now finish this presentation by a short introduction to the last category of additive I wanted to discuss today, which are the elastomeric powders. Sorry. Silicon elastomers are basically three-dimensional network formed by cross-linking and condensation of linear siloxanes. An almost infinite number of variations can be created through the selection of the starting material or the chemical reaction used to create this network. Many silicone elastomers are produced in bulk form, mostly, and a well-known example, we all know it, are the joints that you can form, the seals that you can form in kitchens and bathrooms with the use of sanitary sealants. Less known is the possibility to carry out the cross-linking reaction of the reactive silicone within dispersed droplets in emulsion, leading to the formation of spherical solid elastomeric particle suspension of well-controlled particle size. Once the curing reaction has completed within the dispersed droplet, the resulting elastomer particles can be used either as such or as an elastomeric powder after spray drying. And the impact of using such elastomeric products in coating formulation will depend, among other factors, on the size of the particle that was created. One of the primary benefits is the contribution of the powder to the matting performance, thanks to the light scattering property. The presence of the elastomeric particle on the surface of the coating can also significantly modify the haptics or the touch properties of the surface. They're like little elastomeric balls that are present on the surface and provide a lubrication action which results in a very specific softness and silkiness feel to the surface. The presence of this elastomeric powder on the surface can also significantly improve burnish resistance of the modified surface thanks to their lubricating properties. For water-based paints and coatings, three types of elastomeric powders can be offered. The first type are the solid spherical elastomeric powders as exemplified by the two additives on the left on this screen. These two additives provides the best matting efficiency in the range, but this is not their only benefit. An important characteristic of this powder is that their surface is functionalized by the incorporation of epoxy or metacrylic functionalities respectively. And this chemical modification allows the powder to be chemically bound to the forming film of the coating, which improves the aging performance by limiting the loss of particles through rubbing, for example. These solid powder additives do require some precaution in use and a pre-dispersion in a master batch before incorporation in the final formulation is advised in order to improve the dispersion of the particle and limit the risk of formation of agglomerates. In the middle, a freer flowing powder presenting improved dispersion characteristic and less risk of agglomeration is also available. This powder is easier to disperse in water-based formulation, doesn't require pre-dispersion, but does have a slightly reduced matting efficiency when compared to the other two featured product. Also, in this case, although the dispersion is easier, the surface of the particle is non-functionalized, so it will not bond chemically to the surface. And the third product the third category of product featured here on the right is a dispersion of the elastomeric powder in water. Again, in this case, the surface of the silicone particle is modified by epoxy group. By nature, this product is the easiest to disperse in a water-based formulation. The product, by its reactive characteristic, maintains the surface modification properties of the powdered additive and their resistance to mar and rubbing, but again with the limitation of a lower matting efficiency. Therefore, product selection will need to consider the final performance benefits of higher importance between matting and/or modification of the feel and touch characteristics of the surface. An illustration just to compare the matting performance of the various additives can be seen in this slide. For control formulation free from the elastomeric powder versus 4 of the additive. And the order of efficiency that was described before can clearly be seen, particularly for the water-based version. The modification of the feel of the surface is not illustrated, as this is a property that is extremely difficult to quantify or qualify numerically, and is best evaluated on individual performance via a trained test panel that will feel the touch and characterize the touch of the paint film. So again, this property, for this property, the product selection will need to consider the final performance benefit of higher importance between matting and or surface feel modification. Now, this concludes today's presentation. Through this, I hope to have been able to show that the use of silicone additive in the formulation of water-based architectural paint can be used to improve the properties of these paints, both in terms of appearance and durability. As additives, these materials offer the benefit of low usage level, durability, and compatibility, and will help the formulator to develop more performance products. Many other silicone additives that were not presented today exist in our product range for the end benefit that were discussed, but also to improve release, surface wetting, adhesion, and other end benefits. On our website, you will be able to find additional technical information concerning our full product range of additives for coatings and inks, including product presentations, technical data sheet, safety data sheet, regulatory documents, and more. Also, a product selection guide can be downloaded, which provide a summary of the available technical information on our complete product line in a very condensed and easy to use format. I strongly advise to keep this selection guide handy for easy reference for both architectural, industrial paints, and inks formulation, both for water-based and solvent-based applications, so covering really the whole segment. So thanks again for your attention today. I hope that the presentation was useful. And please, as I say, if you have any question, please submit your question through the question box on the presentation. Thank you, everybody.
Yeah, Stefan, we have to thank you for this excellent presentation concerning your products, the silicone additives. And I think this opened up a lot of perspective for formulators to find solutions that they are seeking actually for. And I'm very sure that there will be, as I know, coatings chemists, an immediate demand of discussions in details and see to gain a better understanding of that to the real problems at the moment of our in our audience. So I think thank you very much. But this is a nice way to find a path to the opportunities that you are offering with your silicon. Thank you very much. Yeah, there was something good, and of course there was something better. As we started our presentation, as you might remember. But of course, yeah. So everybody should be a bit aware of that, what is going on. And we see that questions are popping in here. We see that clearly. And I can tell you and promise you again, this will be transferred directly to DOW. So you will receive an answer from there directly. So what can I say? Yeah. Thank you. Thank you, Stefan. Good luck with your products and all the best. And of course, we have to say thank you to our attending auditory here. Thank you that you take part in our today's webcast. There will be webcast as well in the future. You will see it on the website of the European Coatings Journal. And of course, we have to thank DOW for the sponsoring and the support that we have this webcast taking part. Thank you very much. Again, for further information, please contact DOW directly. So yeah, what is left, as always, is to say goodbye again to the Eastern Hemisphere, so you can have a dinner and discuss the issues that brought by Stefan here. So we are here in Germany and in Middle East and Europe and Africa. We can discuss it with a cup of coffee and a cup of tea, of course. And for our friends from the Western Hemisphere, from the whole America, so you can join now your well-deserved breakfast. So thank you very much for all of you, and goodbye for the next time. Take care. Take care and stay healthy. Thank you very much and goodbye. And thank you, Stefan, again. Thank you very much. Bye-bye.
You're welcome. Thank you, everybody.
Bye.
Goodbye.